Okay. So hi, I'm Nicolò, and we will see together how Babel internally works. And then we will try to implement a plugin, like to understand like practically what we do. You can find my contacts information here. You can ask me any question on Twitter or by email, and you can find me on GitHub. Those are the Babel contacts. As you can see, I put an open collective link because we are funded by the community, and I mean, we work with money given us with donations. Okay, so probably many already know, but what is Babel? It's a JavaScript compiler. It's not a compiler like a C compiler, a traditional compiler, which generates its assembly or maybe binary code. No. Babel is a JavaScript to JavaScript compiler, which just outputs another JavaScript code with the same meaning of the original one. In order to understand how it works, we first need to learn about the data structure that it uses, abstract syntax tree. Why? If we think about how we might transform the input source code, which is just a string, we could think of regular expressions. For example, if we want to replace the exponentiation operator here, we might write a regular expression which looks for words or numbers, followed by the star operator, and then another word or number. We replace it with a math.path call, and we get this output. This works in simple cases, but it has a few problems. It doesn't work well with complex code. What if instead of a simple number or word, we have to match another expression, maybe with parentheses or function calls? And also, it doesn't work well with strings, because that regular expression would also match this operator inside a string, while it shouldn't be transformed. This is why Babel uses abstract syntax tree, and they are used by almost any compiler out there. Here you can see that we have an arrow function expression node, which represents the whole arrow function, and it has a few children, the parameters, in this case an identifier n, and the body, which here is a binary expression, and it has a left operator, a left operand, and a right operand. When we want to replace, to transpile the code, we don't look for the actual source string, but for the node we want to replace. In this case, we are looking for a binary expression whose operator is **, and we don't care about what is on the left side, what is on the right side. We just know that we will replace it with a call expression and using whatever we had as the arguments. And this is the new AST that we get. As you can see, where we had the binary expression, we now have the new call expression. This works well. It solves the problem from before, because since we don't care about what there is on the left-hand side and on the right-hand side, we can transpile like complex expressions, nested expressions without problems. Also, it doesn't have the problems with strings, because strings are just string literal node, and we will never match it if you are looking for a binary expression node. Internally, Babel represents its AST using a normal JSON object. The most important property is type, which is the type of the node, and then every node has different properties. And I will give you like the full list of all the possible nodes at the end of the slides. Okay, now we can take a look at how Babel works inside. Babel is divided in different steps. First, it gets the input source code. It parses it, generating an AST. Then it transforms this AST, and it prints it, generating an output source code. This is done by 3 different packages: Babel parser, Babel traverse, and Babel generator. They are all wrapped inside Babel core, which provides a simple API, because, I mean, using 3 different packages just to compile your program isn't ideal, so we have wrapped them. Okay, the first package is Babel parser. It is divided in different phases. The first one is lexical analysis. This means that it gets your input source code as a string, and it splits it in a list of tokens, which are like the basic building blocks. In this example, we have a keyword token, var, an identifier token, a, then we have a punctuator, a literal, in this case it's a numeric literal, and then another punctuator. During this phase, it reports errors about invalid literals or invalid characters. For example, if we have an unterminated comment or string, if there is a character which just doesn't make sense in JavaScript, or for example, here we have an invalid literal because binary numbers can only have ones and zeros, while there is a 2. Then it performs syntax analysis. It gets the list of tokens generated during the lexical analysis and builds the abstract syntax tree. Here, it finds the var token, the var keyword, which is a token, and so it knows that it has to build a variable declaration node. Variable declaration can have multiple declaration inside, so we have a variable declarator, which is the single piece, and it has an ID, which is in this case an identifier, and an initializer like 7. During this phase, it handles automatic semicolon insertion, because as you may know, semicolons are optional in JavaScript, and they follow some rules. In this example, Babel just puts a semicolon after the first line and after the second line, but it's not always that easy. In this second example, these might look like 2 different statements, but actually it's a single one, and Babel just inserts the semicolon at the end, because what might look like an array literal is in fact a property access on foo. During this phase, it reports errors about tokens, which are valid tokens, but in the wrong position. For example, here we have forgotten a closing parenthesis, and so Babel finds the semicolon token and it throws an error. Or also if we have like valid keywords but in the wrong place. I mean, like if can't be used inside an expression. The last phase is semantic analysis. At this point, we already have an AST, which represents your program, but JavaScript has some rules which disallow some programs. Those are called early errors. For example, you can have 2 properties named __ proto in the same object, or you can use a few statements like with in strict mode. There are many other rules. Also, it reports error about the wrong usage of variables using a scope tracker. For example, if you are redeclaring the same identifier using let or const, or if you are exporting something which isn't usable in the top level scope. In this example, bar can only be used inside the block. Okay, the second package is Babel traverse. It provides a declarative way of visiting every node in the AST. It uses an algorithm called depth-first search, which can run either in order, which means that you first visit the parent nodes and then visit the child nodes, or it can run out of order, which is the other way. So you first visit the children and then the parent. And these 2 orders are called enter and exit in Babel. Okay, so Babel traverse just exports a function, traverse, which gets the AST and an object with all the nodes you want to visit. In this case, we are only visiting call expressions. Then you can specify when you want your visitor to run, if it's in order or out of order. Enter is the default order, so you can just omit it. In order to really understand how Babel traverse visits the AST, which could change over time, it's not static, we will take a look at an example. Suppose that we have 1 plus fn of 3. We want to traverse it, and where we are going out from the function call, we want to replace it with an array, in this case containing 6 and fn. Okay, so we have the AST, and Babel traverse enters the binary expression. Then it goes to its first child, and it goes out from the child. It enters the other child and goes down in the AST, visiting all the nodes in entering and exiting. Then we exit from the call expression, and at this point we have decided that we want to replace it with array. So we replace it with a new node. Babel traverse sees that there is a new node here, so even if it has already visited this part of the tree, it will visit it again. So it enters the new array, then goes in the children, and then goes out to the main program. Babel traverse also performs scope analysis. First of all, it collects all the scope that there are in your program. In this example, there is the program scope, which is always present. And then we have a function scope and a block scope inside the if statement. Then it collects all the declarations which there are in your program. So here we have a let max declaration in the program scope. Then we have the isValid function, 2 parameters inside this valid function. And then we have another max declaration inside the block scope. Lastly, it collects all the usages of the different variables. So here we have big, which is used which references the big in the function scope. Then we are using val and max. Note that here Babel knows that max is the one declared in the block scope and not in the program scope, while here max is the one in the program scope, and so on. Also, isValid counts as used even if you are not calling the function, but it's because we are exporting it, so some other file might be using it. Babel Traverse provides a lot of different utilities to transform your AST or to analyze it. You can search for nodes, remove them, replace them, and it also has different utilities for handling scopes, like to check if a variable is duplicated, to create or rename a variable. The third piece, which composes Babel, is Babel Generator. It transforms the AST to the source code, doing some basic formatting, like inserting parentheses where needed for precedence or indenting the code. We want it to be fast, and we don't really care about the beauty of its output, because it's not meant to be used by humans, but it's just meant to produce code which will be then read by machines. So you can configure it. If you want some pretty printer, you can use another tool like Prettier or JS Beautify. The fourth package is Babel Core. Babel Core is Babel's entry point, which is used by everything which exposes Babel under the hood, like Babel CLI or Babel Loader for Webpack, or we have a lot of integrations for different build tools. It also merges the different configuration files, because you can have a root config file, which is Babel config.js, or a relative config file, or you can pass directly the options to Babel in your build tool. And it runs plugins and presets and collects all the visitors and passes them down to Babel Traverse. In order to learn how to create a plugin, we need to understand two other packages which are less known but are used in every single plugin. The most important of them is Babel Types. Babel Types provides some utilities to validate node. For example, you can check if something is an expression. You can also check if a node has a given property. Like here we are checking if node is an identifier whose name property is test. And you can also provide multiple properties. They can also be other nodes. For example, here, the left property of the plus operator must be a child node that we have got from somewhere else. It also provides a lot of functions to build nodes, because writing the AST as JSON can be quite long. And so we provide one function for each possible node. In this case, we are creating an assignment expression, and the name of the builder function always matches the name of the node that you are creating, and it receives different parameters which corresponds to the different properties of this AST node. The other package is Babel Template. Okay, this code is horrible. So we have a var id node, which references an array. We want to increment each element by 2, and then we want to filter it, taking only the values greater than 10. I would never write this code with Babel types, because it's just too long and it's too easy to get it wrong. And this is where Babel template comes from. We can just write the code that we want, it will parse it, and it will generate the AST, substituting the nodes that we already have, like in this example. You can see that we are using template.expression, but we can build different things like statements or a whole program if for some reason we need it. We can also either immediately get the AST using a tagged template literal, or we can create a builder function which, when called, will give us the AST. Okay, how do plugins work? In Babel, everything is a plugin. By default, it doesn't do nothing. It gets your input code, it parses it, and it prints it again, maybe modifying some formatting. We provide official plugins, which you can recognize because they all start with @Babel. We provide plugins for ECMAScript features like classes, for proposals like optional chaining or class fields, and for a few extensions like TypeScript, Flow, or JSX. And we also have a plugin whose goal is to make your bundles smaller, which is Babel plugin transform runtime. There are many other plugins published by the community, and usually they start with Babel plugins, so you can easily recognize them. Here are just some popular plugins, but there are many more. And often companies have their own internal plugins. How do we create them? A plugin is just a normal function, which takes 2 parameters. The first one is an object containing all the Babel APIs, the utilities like Babel types or Babel template, and it also has a few other functions to get info about the current environment. The second parameter is an object, which represents the options of your plugin. This is because the user of your plugin can define some options in their Babel config, which are not related to Babel, but to your specific plugin. This function must return an object, which must have a name property. This is used, for example, if there is an error, we attach the name of the plugin to the error so that the users of your plugin can easily understand where it comes from. A plugin can then return a visitor property, which contains all the visitors which will be passed to Babel traverse. As you can see here, this call expression visitor is getting a path parameter, and we will see in a few minutes what it is for. We can also provide a manipulate options function, which takes the Babel options and can modify them. So, for example, you can enable some flags on the parser or on the generator. Or you can also just replace the parser with your own fork. And a plugin can extend another plugin. This is useful if you want to add some functionality without just copying all the code. Okay, so what was that path parameter? When we have an AST, we have just links from parent nodes to their children. But this isn't the best thing when we need to transform the AST, because we need more context. This is why we have a node path, which is a wrapper around the AST, which links every node to its parent, to its children, to its siblings, and it provides a lot of utilities. Also, since Babel Traverse builds the scope chain, every node is then linked to the corresponding scope so that we can easily, for example, understand if a given variable is declared in the current scope or in a parent scope. Okay. This node path has a lot of utilities. For example, the paths.node property allows us to get the original node, We also have utilities to walk in DST to get the parent, or we can get a deep child specifying the walk path. We have path.scope, which exposes all the scope-related utilities. And we have a few methods to remove nodes, replace them, or insert them. Lastly, the path.toString method, which isn't used in a published plugin, but it's really useful when debugging, because understanding what a node path represents can be hard because it's a big JSON object, but with path.toString, we can print it, generate the corresponding code so that we can quickly see if there is a problem. There are also all the scope-related utilities, like scope.build undefined node. This is used because in JavaScript, undefined is just a normal variable. You could literally redeclare it. For example, you could set it to 2. And so using the undefined word in a program isn't really safe. I mean, if it's your program, it is, because probably you aren't redeclaring undefined. But we want to be sure, so we provide this utility, which returns a node that at runtime will just evaluate to undefined. Then there are a few utilities to generate variables and to push them in the current scope, and to check if a binding or a variable is declared or not. Okay, we can now take a look at a real example of how to implement a plugin. I chose the optional chaining proposal, which is currently in stage 3. And it allows you to get a property from an object which might be undefined, avoiding all the cannot get prop of undefined errors. In all JavaScript, or well, maybe it's current JavaScript, you can use, we usually use the AND operator. Like here, if we don't know if address is defined, we use this code. This is a bit different from the optional chaining operator because of falsy values like 0 or the empty string, which will, using optional chaining, we will get the property on falsy values, while with AND, we are bailing out. And optional chaining also looks way nicer when we have complex expressions, like in this example. Okay, we can now code together this plugin and see how to do that. It's drinking time. Okay, I've prepared this editor. On the left side, I will write the plugin. And on the right side, you can see the input code we will give to the plugin and the output code. If there is any error with our plugin, it will be shown in the output code. Okay, so as we said, a plugin is just a normal function. Okay, and we have to export it just because so that it can be used. This function takes 2 parameters, which are Babel and the options. Okay. As I said before, this function must return an object, which has a name property, and we can call it like optional chaining plugin. Okay. We can let's check that this is doing something. Okay. Let's try to see how it behaves with optional chainings. Like if we have a (b). The plugin is throwing an error that the optional chaining syntax is not enabled. This is because by default, Babel only parses stable features which are already in the spec, and it doesn't parse proposals because they're still experimental. So we can use the manipulate option function to tell the parser that it should parse this feature. This takes the Babel options, and we can enable the parser plugin. parser plugins are not real plugins, they're just like flags. Okay. As you can see, Babel is now parsing this syntax, but it's not transforming it. Just because we haven't defined a visitor, we haven't defined how it should be transformed. So we can return a visitor property. Okay. The name of the node used for optional chains is optional member expression. Don't worry, I will give you the list with all the nodes, the node types if you're interested. Because, I mean, there are a lot and it's impossible to know all of them. Okay. We can already start taking the utilities that we need, so Babel types and Babel template. Usually we alias Babel types, we will alias Babel types just to T, just because it's short and Babel types you use frequently. Okay. Optional member expressions have different properties, like, well, they have the type property. Then they have an object property, which represents the object, and a property, which is the property we are maybe getting. It also have two other Boolean flags, which is computed, which is needed to differentiate between normal property access and array-like property access, and an optional property. Optional is needed because if we have nested property accesses, like in this case, they're all optional member expression nodes, but we know that the question mark is only in the inner node because it has this optional property set to true. Okay. So we can get the property, the object and the property from the original node. Okay, and we can replace the current path with the new node that we want to build, and we can use Babel template to build it. So it's path.replace with, and we build our template. Okay, so we want to check if the object is null or undefined. I'm using 2 equals for this instead of 3. If it's null, if it's nullish, we want to return undefined. Otherwise, we can return the property access, which is a.b. In order to return it, we first have to build this new node because it's not an optional member expression anymore. It's just a plain member expression. So we can do member exp is equal to, we can use Babel types here. And it gets the object and the property as parameters. Okay, we can use it in our template. Okay, I haven't closed the comment. Okay, as you can see, this basic transformation is now working. We are, I'll just put it there. Sorry. This basic transformation is now working, but it has a few problems. First of all, we said that someone could write this in their code, which is bad, but it's possible. And in this case, here we are returning 2 instead of undefined, which is not correct. So we can use the utility from scope we saw before, which is path.scope.build undefined node. And we can use this fake undefined here. Okay, now it's using void 0. Void is an operator which is not much used in JavaScript because it just takes a value and then returns undefined. So it's guaranteed that it always returns the real undefined. Okay. Now let's take a look at another problem that we have, which are computed property accesses, like array-like. Here we have an error telling us that we are trying to get the property 0, but it only works with identifiers or private names. This is because we also have to specify which is computed. So we can pass that. We get it from the original node. Okay. So we can specify that it is, if the original node is computed, also the new one will be. And if we just use .x, it will build .x. Okay. Now, what if I have not a simple identifier, but something like a function call? This is transpiling it, but as you can see, there is a problem. In the input code, we only call a once, while in the output code, we are calling it twice, once to check if it's null, and once to get the x property. And this is wrong. We can avoid it by storing the result of the first call in a temporary variable, and then use this stored result to get the x property. To do this, Babel provides a few utilities to build an identifier which is guaranteed not to conflict with anything else in your program, which is like temporary variable. It's path.scope.generate UID identifier. Okay. And we can call path.scope.push, which will push this variable into our scope, which means just which is declaring it using var. So path.scope.push, and the ID, I'm really sorry, is temp. Okay, as you can see now, we have a temporary variable. We can customize its name a bit. For example, we could tell Babel that the name should look like obj. Well, just so that we understand what it is in our output code, because having every variable named temp isn't nice when debugging. Okay. And now we have to store the result of the possible function call. So it's temp equals to object. And then, okay, so we are storing it. I mean, this is formatted pretty badly. So, okay. I like this more. And we now have to use obj inside our member expression. So here, instead of the object, we are just using the temporary variable. Okay. And this is not only a problem with call expressions, because if we had like a.b, maybe b was a getter, and so it isn't safe to get b 2 times. So it's convenient to always store the property in the object in a temporary variable. Okay, so this is working well in cases where we are getting an optional property from an object. But what if we have more than one nested property? For example, we are getting x.y.z. Okay, just don't take a look at the output code for a moment. The input code means that we are checking if A is nullish. If it's not nullish, we want to get x.y.z. We are not checking if those things are nullish. Otherwise, we would have put other question marks like this. Oh, it's not working. Well, I mean, done. Okay. While in the output code, it's checking different things instead of only checking A. So, what can we do? We are currently visiting this, starting from the outermost node and going to the inner nodes. But we should only transform the nodes where the property named optional is true, which means that there is the question mark. So we can go down in the EST until we found the real optional property. So while the current path is not optional, we get its children, its child. Okay. So we first visit .z. It's not optional, so we get the path of the object, which is in this case is all this expression. It still doesn't have the question mark, so we go down to x. X has the question mark, so we stop. And we can just store the original path somewhere in case we need it. Okay. So let's see what this does. Okay. Okay, well, it's not working. Let's see a simpler example. Okay, I will try to understand what's wrong later. For now, this works with just two properties. But it's still not producing the correct output because we don't want to replace the current path, but the original one. And we want to build the property access. Oh, I know why it's not working, because I'm getting this before the loop. Okay, well, it's not working, but I did expect this now. We have to add .y after the x. So instead of just building a member expression using the current path, we have to wrap it more times. So we can start with the temporary variable, and then using a loop, we add all the properties. I'm using while true for now, and we will check it later. Okay, so the new member expression is a new member expression, which wraps the old one. And the property is the property of the current path. And we also have to get the computed flag. Okay. After building this member expression, we have to go to the parent path because we are now going up in the AST tree. So we replace path with its parent. Okay, and when we want to break from this loop, because now it just goes on indefinitely, we want to break when we have reached the original path. But we first want to build the member expression of the outermost property access, and then we want to break from the loop. So I'm just putting an if path is the original one, break. I've pre-declared a variable. Okay, so now this is correctly storing A in an object, and if it's not nullish, it's getting obj.x.y. Okay, here I think that they are not used anymore. No, we are not using them. Well, properties not used. Okay. Okay, so this is now working quite well. It's handling complex expressions. It's handling array-like notation, and it also works with nested things. Here we are checking both A, and then we are checking the result of A.x, y. So it's correct that it's checking it twice. Okay. This proposal also implements optional call expressions. I won't implement them now, but I will give you a link to this code at the end. So if you are interested, you could download it and try adding support for optional call expressions. What time is it? Okay, I still have 10 minutes left, so I would like to talk about loose mode. which is a common option which is present in many of the official Babel plugins. As you can see here, the generated output is much bigger than the input code. And this is because we have to match the same semantics. And if it was already easy to represent this thing in old JavaScript, we wouldn't need the new syntax. But this is a problem because I don't want to ship a lot of bytes to the browser. This is why Babel often implements loose mode. This means that it generates smaller code, maybe faster code, but which isn't really spec compliant. It works well in most cases, but it breaks if you are doing something weird. For example, we could transpile this to the current JavaScript using a and a.xy. And this is not really correct because if a is false, they behave differently. But it works well in most cases. So we can add a loose option to our plugin. I'll just get it from the option object, which defaults. Okay, and if I want to test this option, I have to enable it in the Babel config. So I'm just going here, and I'm passing the option to the plugin. Loose true. Okay, let's go back to the plugin. Okay, so now we get this loose option, which might default to false, because we want spec compliancy by default. Okay, so we can, instead of just building this AST, we can, if you are in loose mode, we want to do something. Otherwise, we will use the more correct logic. Okay. So here we will now use another template from Babel template, but I want to show you how to create a builder function. So we can call it build loose, which generates another expression. And instead of using the tagged template, we just call it as a function. We want to store temp in the object in temp anyway. But, I'm doing it wrongly. Okay. When I want to create a builder function, I can't use template substitutions, but I have to define some placeholders like temp. And we use this %% syntax because it doesn't conflict with any other valid JavaScript syntax. So we have temp, and we store object inside temp. And then, if it's true, truly, we get the expression. Okay. So now we can replace the path. And we are now calling this builder function, this AST builder, providing all the placeholder that it expects. So we have temp, which was called temp. Then we have object, and then we have exp, which was our member expression. Okay. As you can see now, it's generating this simple code in loose mode, and if we go back to our config and disable loose mode, it will generate the more correct but longer code. Okay. Lastly, I want to talk a bit about plugin testing because, when we write a program, unit tests are often useful, especially when writing a Babel plugin. Okay. We use an internal package to test our plugins, but we haven't been recommending it to the community. And so the community came up with another plugin, with another package, which is called Babel Plugin Tester. And it uses Jest. Okay, so we can install. Okay, so we can install it, and we also need to install Jest. Okay, I'm joking. I already did this, so I won't install them now just because it takes time. Okay. Okay, so I have my files. So we can define test folders for Jest, where we import our plugin tester, and we import our plugin. I'm closing this. Okay. The plugin tester package exports a function which takes an object with different options. The most important options are plugin, which is our plugin that we want to test, and fixtures. This is because Babel plugins are usually tested by having a lot of possible input files with the corresponding output files. And when we change our plugin, we just check if transpiling all the input files still gives us the correct output files. And fixture is a folder containing different folders, each one with an input file. In this case, I have created two different tests. Okay, so now I can run Jest. And since there isn't currently the output file, it will generate it. Okay, so it has generated the output file for the first input and the output file for the second input. If we now introduce a bug in our plugin, which I can do like this, bug, and I run Jest again, it will give us errors telling that the output doesn't match anymore. It gives us a diff. And here we can see that there is the bug, and we can try to fix it. If instead the new output code is correct, we can just like delete the old output file, run Jest again, and it's still giving us an error about the second test because the output file is still the old one. But for the other test, where we decided that the new output was correct, it generates the new output file with the new output. Okay. So that's all. If you have any question, you can ask me now, or I will be just after the talk. I will be hanging around. And here are a few useful links. The first one and the second one are just links to our documentation about our AST. Then I've put a link about the proposal so that if you're interested, you can check how optional function calls should work. And then I have a link to Babel plugin tester and to the GitHub repository containing all the code of this talk. The slides are published on the HolyJS website, so you can find there the slides with all the links. Thank you.
Okay, thank you. So, take a seat. Okay. So, the first question is, how long does it take for you to maintain Babel?
Okay, that's a good question, because Babel is a really big project, and we are only a bunch of mostly volunteer people. We currently have one full-time maintainer, which is paid using the donations that we have. But this isn't enough. Babel is not my job, but I'm dedicating a lot of time to it, as well as other team members. This is why we are trying to hire ourselves as part-time maintainers, but we are still looking for the sponsorships to be able to do so.
How you started to?
Sorry?
How you started to contribute to Babel?
When I first approached open source, I wasn't contributing to Babel, but to another project, which was JS Hint, which is a linter. And this is how I got really interested in parsers. Then the project is almost dead now, and I had to look for another interesting parser. And I was a Babel user, so I knew that there was Babel parser, which at the time was called Babylon. I started contributing to the parser, and after a few months, the team asked me if I wanted to become a maintainer of Babel, and I just joined the team like this.
Okay, for modern Babel, I believe it was introduced in version 7, maybe I'm wrong. Another approach, instead of building plugin for solving several tasks, was introduced called macroses via Babel macros. What's the difference?
Okay, first of all, macros are not maintained by us, but I think that they're maintained by the same author of Babel plugin tester. The difference is that with plugins, you can do much more. For example, you can more easily transform new syntax, or you can build more complex transforms. On the other hand, macros are really handy because you don't need to add them to your Babel config. You just import the macro in your source code, and you can use it as if it was a normal function, and then it will be transpiled.
Okay, your really great live coding missed one part, which was like writing feature parser, so support the optional chaining. How complex is that one?
Okay, the Babel parser doesn't support plugins. That plugins option that I was using in the code is just a list of features which the parser already supports but are disabled by default. If you want to test your custom syntax, we don't yet, at least, provide an API to do so, and we suggest to just fork the parser, and then you can provide your custom parser as a Babel option.
Okay, just to make understand. So, for example, each time the parser supports a number of different syntaxes, including all from stages, like stage 2, stage...
We don't have like a rule for this. We try to implement plugins, parser plugins soon, unless the proposal is really unstable. For example, there is currently a pattern matching proposal, which I think is stage 1, but could be stage 2, I'm not sure. And we have not implemented it yet, just because the syntax is changing really fast, and so we aren't willing to commit to these frequent changes yet.
Okay, if, for example, you are not a Babel maintainer, but, for example, let's see a usual developer in an outsourcing company or in product company, how Babel plugin development could be useful for such developer?
Often companies are writing small plugins which to make their product faster or to make it easier to instead of writing a repetitive code many times, you can just write a plugin which duplicates some code, or you could write a custom plugin which, instead of calling a function at runtime, just is able to replace this function with something which is specific to your program to avoid some runtime cost.
Okay. The question is, does order in which Babel plugins are used matter? And how do you solve collisions and part of some Babel's plugin transformation have to also be transpiled by the next plugin?
Yes, it matters and is currently one of the worst part of Babel. Because there are a few rules for plugins ordering, which are that plugins run before Babel presets, and I think that plugins run starting from the first one to the last one. And there are a few features for which different plugins need to transform the same node. For example, a recent bug we had was that, I don't know if you use TypeScript, but you can define a parameter in the function which is used to annotate the type of this. And we had a conflict with another plugin which transforms parameters, which was the one for REST parameters, because first the TypeScript plugin needs to remove the this type, and then the other plugin must transform the function parameter. Otherwise, it just doesn't work because it counts one more parameter. So plugin ordering is hard. We have been trying to solving it to make it like to automate it for 2 years now, but we have never finished like any PR, and they were just had too many problems. We are trying to document in which order plugins should run, but
okay. One of the complex thing when you're writing any real code transformation plugins is to make sure you do not pollute the scope and that you are not messing with the scope, like any potential conflicts. Are there any additional tooling except which you used for live coding, like generating unique identifiers, creating predefine it and define it, and so on, or this is enough?
I mean, this is enough usually, because if we know the name of every variable in the current program, we don't risk conflicting. There is a problem, which is if you include multiple JS files in your HTML, they will all run in the same scope. So if we generate a var, for example, var temp in one file, and then we transpile another file, we don't know that there is a variable with the same name in the first file, and so there could be a conflict. And this is not a real problem in practice because people use Webpack or Rollup. So,
okay, how Babel deals with speed? I mean, as user transforms you're writing targeting to be speed efficient, are you measuring speed of your transforms?
okay, so there are two different speeds that matter. One is the build time, and the other is the speed of the generated code. We have not been really thinking about speed so far because Babel is often used like a testing tool for new features other than transpiling. But we are now starting to optimize it. We have a few PRs which optimize the output code, and in every minor release, we are making it a bit faster, especially because there is a new team member which is really interested in this. For example, I don't know if you saw it, but we just released Babel 7.7, and it uses, I think, 20% less memory. So, well, I did not do that improvement, but
Okay, just curious, it's a question from me. There is two controversial opinions in Node.js community. Like, should you use Babel with Node.js, and is this a healthy decision? Or like running a transpiled code in Node.js is not a good decision. What's your point?
Well,
server-side development.
When I write a few small projects with Node, I don't use Babel, just because if I can avoid using a build tool, it's way easier. Babel is mostly useful for browsers, or if you're publishing a library for Node, because the users of your library might want to use it on an older version than the one you're using. But if you are writing a small tool or a small application, you often don't need Babel if it's only for Node.
Okay, thank you for your answers. It was a really great session and great live coding. And see you in discussion area.
Thank you.